Hi everyone, welcome to the third lesson of chapter 4, class 12 physics, moving charges and magnetism. In the previous class, we derived the equation for force acting on a conductor placed in a uniform magnetic field. In today's lesson, we are going to learn about velocity selector and Lorentz force. We will discuss what is Lorentz force. Lorentz force. You know, when a charged particle moves through a uniform magnetic field, it will experience a force. That force is given by F is equal to VQV sin theta. If we apply simultaneously an electric field also, the charged particle will experience both electric and magnetic forces. So Lorentz force is the force experienced by a charged particle in combined electric and magnetic fields. Okay, so you have to subject the charged particle to combined electric and magnetic fields. The force acting on a charged particle in combined electric and magnetic field is known as Lorentz force. Lorentz force. Lorentz force. What is Lorentz force? It is the force acting on a charged particle under the combined electric and magnetic fields. You know, due to magnetic field, the force is F magnetic QVB sin theta or Q into V cross B. This is the force due to the magnetic field. And what is the force due to the electric field? If you apply an electric field, force due to the electric field is Fe, force due to the electric field. It is Q into E. So the sum of these forces is known as Lorentz force. So Lorentz force equals Q into, add these two forces together, V cross V plus Q into E bar. So Q into V cross V bar plus E bar. This is known as Lorentz force. So what is Lorentz force? It is the force acting on a charged particle under the combined effect of electric and magnetic fields. Now we will discuss the motion of a charged particle through combined electric and magnetic fields, which are perpendicular to each other, which are perpendicular to the direction of velocity also. Okay, we are considering the motion of a charged particle in perpendicular electric and magnetic fields. Both are applied simultaneously, perpendicular to each other. Such fields are called crossed fields. Motion of a charged particle under the combined electric and magnetic fields. Which are perpendicular to each other. Okay, children? Okay. Now you consider a charged particle. This charged particle is moving along x direction. So velocity I am writing as v I hat. I hat denote x direction. Now I apply a magnetic field along z direction, positive z direction. Magnetic field is along positive z direction. Magnetic field B K hat. Okay. Then what will be the direction of the force due to the magnetic field? You know, force is equal to Q into V I hat cross B K hat. So Q into V B into I cross K. You know, I cross K is minus J hat. So into QVB. So this magnetic force is along negative y direction. So this is the direction of the magnetic field, negative y direction. This is magnetic force, right? QVB minus J. Minus J means it is negative direction. Now the charged particle was moving along x direction. Now you apply an electric field simultaneously in the opposite direction. Suppose electric field is in the J direction. So you apply an electric field. This is electric field in the J direction. Electric field is represented by EJ hat along y-axis, positive y-axis. So what will be the direction of the force? Then direction of the force will be in this way. F is equal to QEJ. Okay, we are considering positive charge only. So direction of force is along y direction because electric field is along y direction. Force due to electric field all along y direction. So force due to electric field is Q into E J hat. So what is the total force? Total force that is known as Lorentz force. So Lorentz force is Q into what is magnetic force? VB. Q into VB. That was minus Q into VB plus Q into E. Okay. If these two forces are equal, this is the total force. If these two forces are equal and opposite, what will happen? We can write 0 equals Q into E minus VB. Okay. So if these two forces are equal and opposite, then what we can write? They cancel out. 0 equals Q into E minus VB. Or you can write E equals VB. Or V equals E by B. This is a very important relation. Okay. So when these two forces are equal and opposite, you can see the charged particle will move along the x direction undeflected. Okay. Such fields are crossed fields. This arrangement is known as velocity selector. Why it is so called? Suppose many charges, many particles of different charges and mass are allowed to pass through this coil. You can see only the particles having constant speed. They are moving with the constant different speeds. Only particles having the constant speed V will pass undeviated, pass straight. So we can separate particles of a constant speed from a collection of large number of charged particles with the different speeds, mass and velocity, right? Only particles having a constant speed will pass undeflected. This arrangement is known as velocity selector. Okay. This has an application. It is used in mass spectrograph. Mass spectrograph. What is this mass spectrograph? It is a device to separate charged particles having different charge to mass ratio. Okay. If they have constant speed, particles are having different masses, different charges, and they are allowed to pass through this velocity selector. Only charged particles having a constant speed will come out. This therefore, this arrangement is known as velocity selector. Okay, so what is Lorentz force? It is the force acting on a charged particle under the combined effect of electric and magnetic fields. Okay, children. Today, I am ending the class. We will see next class. Goodbye.